All right, guys, we're out here in my backyard, and check it out. There's a new antenna on the test pole. Back to doing my homemade stuff. This is a end-fed half-wave vertical, set for 27 megahertz. Let me bring you in. If you remember, if you watched that video I just did recently of that long wire, it came with a 64-to-1 Balun in it. And after a quick little bit of research, I found out that that Balun can be used on pretty much any half-wave antenna for the HF band. It was set on that 130-foot wire so that it would work multiple bands. But I built this out of aluminum piping and put the Balun on there. Now, it's not going to be a high-power antenna. That's only a 150-watt Balun. The Baluns typically don't handle a whole lot of power. You can spend some money and get a up to 1,000-watt Balun, or you can just go with like that one. That one's a 150-watt Balun, and those are roughly $25, $30 eBay or Amazon. The 64-to-1 or a 49-to-1 Balun will work for this project. All right, let me show you some clips of the build, and then we'll show you the whole antenna when it's laying down. Then we'll do some testing. So at the base of the antenna, the bottom section, this is where it gets tricky, because the antenna has to be isolated from the mast that it's going to be mounted to. And we need something strong enough to hold this all together. Well, you know me, I work with what I have. And what I came up with pieces and parts that I have, that will be the bottom section of my antenna. And then I sleeved it. So we have some extra strength, but it's mostly just to take up space. Those pipes go in, the same length as this one. This pipe is the same length. So it's roughly a little more than a third of the way up the bigger pipe. So those fit nice and snug in there, and I got a set screw to hold them all together. Then, inside of that, this fiberglass rod is going to go inside of that pipe, and then this fiberglass rod goes over that 2-inch nub, and we'll lock it together right there. And then this pole is the one that will get mounted to the mast, and this piece is the spacer, because this fiberglass rod is narrower than the inside diameter of this fiberglass pipe. So this will go over this and inside of this to take up space, and it'll also add some strength down at the bottom. Down at the very bottom of it, where it'll be mounting to a mast, it'll have all of that inside of the big one. And then it'll go up from there, and we'll have the two sections of fiberglass there. We got the 2-inch down into the big fiberglass, and then the small fiberglass fits up inside of the 3 pipes that bottom piece is made up of. All right, let me get this all put together, and we'll work on the next part of the antenna. All right, check it out. I've got the Balun attached, and if you're already thinking that copper wire shouldn't be on the aluminum, it's not. See that little triangle piece behind the copper? There's a piece of stainless steel against the aluminum, and then the copper wire is sandwiched between that piece of stainless and the stainless clamp. Then I just taped and zip tied the Balun right to the mast. Right to the antenna, actually. And just a short piece of wire. And remember, that nub from the antenna actually sticks down, so I'm not worried about this piece of wire acting as part of the antenna, because the actual antenna comes down the exact same length as that wire. That'll work. It's on there pretty well. It should stay in place. Those screws that I use to fasten everything together, because remember, there's 3 layers inside of this pipe. These are from a steel shed kit. Those are the I won't say they're rust free, but they have a rust preventative coating on them. I don't need them for connection, I just needed them to hold everything in place. So those will work well. Actually, let me show you one of them. Oh, I got it over here. It's just a little, it's a sheet metal screw that's made for the metal sheds. But I got two in up here that I'll go through the half, one side of all three pipes. I have one there, and then down on this end, I have two on that end. Because inside, remember, there too, there's a fiberglass rod, then there's the aluminum sleeve, and then there's the fiberglass tube. And the aluminum sleeve goes up probably to, oh, around there somewhere. So we got a good strong area to mount it to a metal mast, and that'll keep the entire antenna away from the mast. All right, I'm gonna go put the rest of this together. Probably end up taking up the full length of my garage. It's on the test pole. My makeshift pole. Pieces and parts and whatever I had put together to get this thing. Right now, the bottom of the antenna is going to be 19 feet. Just over 19 feet off the ground. And it's just hose clamped to that mast. And a couple of zip ties just so that we don't end up pulling the coax on the box. Came out pretty good. Look at that. It doesn't bend much. That is pieces and parts. Oh, this was a piece of aluminum a friend gave me. That was from an old Radio Shack antenna. They had a bad coil in the base of it. Oh, this one I believe also came from that Radio Shack antenna, and then the top two parts from an old Mako beam. For each section where they join together, I have it clamped. It's notched and clamped, and I've also put in two screws. So we have it set up like the Mako does it, and like Serio does it. Camera's having trouble focusing on that. But I got those rust-resistant screws at every joint. Clamped and screwed. Two screws and a clamp. This is the only one that I did not do that to, because this is the tuning end. Check it out. Just starting out, I just put it up in the air. On channel 38, we have 1.38 and 67 ohms of resistance. I'm going to drop it back down and do a little bit of tuning. Some last minute tuning that I did on it. I had to drop it down to add some strength to the mast. And while I had it down, I slid that top section in just a little bit more. Now on channel 38, we have 1.11 to 1 SWR and 55 ohms of resistance on channel 38. Let's see what the built-in SWR checker on this President Washington, let's see what it has to say. We're on channel 40 at the moment. Dead flat according to the Washington. I had that mic out of my reach and I need it to bring back the display. Alright, that was channel 40. Let's go all the way up to the top. I will only be using this antenna probably between 26 megahertz and 28 megahertz. At 28 megahertz, wow, look at that. 1.1 at 28. 28.005. Let's go down. We already saw 40. 40 was dead flat. Oh, let's go to the middle of the band. We're now on channel 20. And on channel 20, dead flat. Let's go right down to 27 megahertz. Hoo-wee, look at that. Dead flat there too. Let's go to 26.5. At 26.5, we're up to 1.1. .26 megahertz. At 26, we're at 1.2. So staying below 1.2, we can go all the way from 26 megahertz all the way up to 28 megahertz, staying below 1.2. That's a really broad-banded antenna. Let's see what else we got. 25.5 megahertz. 1.3. Let's go to 25. 25 megahertz. What's your guesses? 1.4. Yep, we're reaching the end of where this radio will go. 24.7 megahertz. 1.5. Now it's easy to get to the top. One click backwards and we're at the very top. So this radio is usable from the very beginning. This antenna is usable from the beginning of the frequency coverage on the President Washington. And at 30.105, which is the highest frequency this radio does, let's see. Well, a little higher than what I would like, but it's still usable. 1.6 at 30 megahertz. Let's go down to 29 megahertz, because we know it was 1.2 at 28 megahertz. 1.4 at 29 megahertz. And yeah, if we go back to 28 megahertz, which actually drop right to there. This is the highest I will ever use the radio. And there, oh, 1.1. Oh, that's right, it was 1.1, wasn't it? So we have 1.1 to 1 match at the top of the 27 megahertz. And then we can go all the way down to 26 megahertz and also be at 1.1, I believe. Oh, 1.2. Damn, that thing is broadbanded. Holy moly. 151, South Carolina. Looking for an antenna check.
Just go outside and take a look up in the air. It should be there.
Copy that. It is in the air. I just put it up there. It's a homemade half-wave vertical. How's it doing over there?
Yeah, you're doing fine. I've got 4 S units on you, and I can hear you pretty good.
Copy that. Thank you very much. You got 151 in South Carolina on this end. Who do I have over there?
You got 524, Dave, and you hit me with a 5 at that time.
Copy that, 524 Dave. You're doing 6 to 7 over here on my end. I'm running a brand new President Washington, and like I said, a half-wave end-fed vertical antenna.
Well, you got it working. It's working pretty good. I got 7,300 with, oh God, I forgot, Vector 4000.
Nice, very nice. That's a nice and a tall antenna. It's working well for you. You sound fantastic on the air.
All right, so there's a lot of them out here. I'm going to get back on the side here.
Copy that, Dave. Have yourself a fantastic day. Thank you so much for the antenna check. 151, South Carolina. I'll be clear.
7-3.
Well, we just got a radio check. And it seems to be doing pretty well. We got some, even though DX really isn't doing much today, we still made a contact with it. It's going to stay in the air for a while. I want to play with this one for quite a while. It works fantastic. The receive is really, really good on it, too. At least comparing it to my 3-element Mako V-Quad. It doesn't receive as well as that, but it's close. It's not that far off. All right, guys, I thank you for watching, and we'll catch you on the next build.